Okay, we're going to look at an example of how to find all the real zeros for the polynomial function that we see below. So, same process we went through in class. So the first thing I'm going to do is I'm going to look for possible rational zeros. And possible rational zeros are the p over q, where p are the factors of 8 and q are the factors of the leading coefficient, which is 1. So this is a pretty easy one. Anytime q is 1, it's pretty easy. So the factors of 8 are 1 and 8, 2 and 4. And the factors of q, which is 1, is just 1. So the only possible rational zeros, the only nice ones, are 1, 8, 2, and 4. Now, there could be other zeros, obviously, but they're going to be either irrational or eventually complex. So, one way to do this is obviously plug in these numbers, plug in these 8 numbers and see which of them give 0. Or we can certainly look at a graph. This graph I did on Desmos. You can do it on a TI calculator because we're just looking for numbers off of this list that are x-intercepts. And as you can see, I see 2 of them. I see 4, 0 is a good one, and I see 2, 0 is a good one. The other 2 are really decimally. They're some kind of irrational numbers. That is not acceptable to put as an answer. We have to figure out what those are. So, what we'll do of our 4 zeros, because we are looking for 4 zeros, because it is degree 4, at most, we have at most 4 real zeros. We know 2 of them now. We know -4 and 2. So we got to find the other 2 missing zeros. So once you know some zeros from the graph, what we'll do is we'll go ahead and we will get our polynomial to be a depressed polynomial by dividing those out. So we'll take -4 and we'll divide it into the polynomial. 1, 4, -5, -18, 8. And obviously if we did this right, this should give us a 0 remainder. And it does. So that's our 0 remainder. Now, because we know 2, now if you just knew 1, then you would just solve the resultant equation, but we actually know 2. So now I'm going to divide it, I'm going to ignore the remainder, and I'm going to divide my other 0 that I know into the remaining numbers. Doesn't matter the order, I could have done 2 first, doesn't matter. 1, 2. 0 plus 2 is 2. 2 times 2 is 4. -1, -2, 0. Now, because I started with a 4th degree polynomial and I divided it out twice, that's going to reduce the degree by 2, so this has to be just a quadratic. X squared plus 2x minus 1. So to find my other 2 zeros, all I'm going to simply do is figure out when this is 0. So now, sometimes you get lucky and you could just do square root property. In this case, we're going to have to do quadratic formula. So remember quadratic formula, -b plus or minus square root b squared minus 4ac all over 2a. So that's -2 plus or minus square root b squared, which is 4 because that's 2 squared, minus 4 times a, which is 1, times c, which is -1, all over 2 times 1. So if I simplify under the root, I'm going to get -2 plus or minus square root of 8, because you have -4 times 1 times -1, over 2. Now root 8 simplifies as root 4 root 2, so it's 2 root 2. So I get -2 plus or minus 2 square root of 2 all over 2. Now this 2 in the bottom, I can simplify, just divide everything by 2. So I get -1 plus or minus square root of 2. So my other 2 missing zeros are -1 plus root 2, -1 minus root 2. And if you put these in your calculator, if I put in what is -1 plus root 2, it should tell me approximately 0.414, which is what the graph says. So you can check it that way. 1 minus root 2 is approximately -2.414, which is what the graph says. So the key is find the zeros you know on the graph, divide them out, and then use quadratic formula, square root property, to find the remaining couple.